Well, I'm so glad you asked because that actually jumps us into our lesson. Wow. So, this is my favorite fish. It's called Aduncleosteus, and it's an index fossil of the Devonian. So, I am not sure if you guys remember what index fossils are, but if not, that's okay. We'll review today. And I like it because it looks very cool. And it will not bite you because it is extinct. Okay. I can't argue with the monkey superiority. Okay. So the agenda for today, as promised, we're going to be doing a gym kit at the end. You guys can choose the mode. And then the lecture today is going to be pretty long, so we're not going to have a review game at the beginning, but instead we're going to have one big giant review game at the end with the gym kit. And thus we begin. So first, a review.
Okay, because I need my mouse. We'll do game.
Okay, yes, be prepared, ready for the battle. Okay. So I'm gonna mute.
Oh, okay.
No. Okay, so a review of geologic time. So first, we're going to be looking at the Precambrian supereon, which consists of the Haitian, Archeon, and Proterozoic eon. And then we're going to be looking at the Phanerozoic eon, and specifically the first third of the Phanerozoic eon, which is the Paleozoic era. So, the Precambrian supereon. So, what is the Haitian eon? So it's the oldest of the eons in the Precambrian, and so it was about 4.5 to 4 billion years ago, and it was originally said to be the beginning of Earth before any life, but there has been some evidence of liquid water from 4.4 billion years ago, so there was possibly life. So something you need to take into account when you're actually looking at fossils and geologic history is that everything is pretty relative. We don't know anything exactly because obviously it was a really long time ago. Most of the evidence we have is from like fossil record and rocks that have broken down over time. So you may have different sources that are like off by maybe plus or minus 10 years or 10 million years from each other. And you just need to know that it's around that general vicinity and to take everything you see with a grain of salt. So what I'm teaching you right here may be different from what like National Geographic says, but that doesn't mean that this isn't accurate. It's just I use different sources. And so yeah, it's all very relative. So the Haitian eon is actually an informal division of time. So it's not an actual eon, but it's said to be the time before any life on Earth. And so during this time, the planet was characterized by a partially molten surface, lots of volcanoes, and also lots of asteroid impacts. It literally looks like the underworld, so that's why it's named after Hades, the Greek god of the underworld. A lot of the names in paleontology are named after like Romance languages like Greek and Latin, and yeah. So during this time, rocks were just starting to form as the surface started to cool down because as you can see in the picture, everything was pretty much on fire. And so the moon was also formed during the Haitian eon. So again, as you can see from the picture on the left, this is what people visualized the Haitian eon to look like. And it's basically just fire. So what is the Archean eon? So it's the earliest formal division of time from 4 to 2.5 years ago if we exclude the Haitian eon. So during this time, the records of Earth's primitive atmosphere and oceans begin to emerge, and also we have the earliest life, which are prokaryotes, which means that these animals, their cells do not have any membrane-bound organelles. So there's no like mitochondria to perform cellular respiration or like breathing, no photo. And then, yeah, so the earliest life would be bacteria and archaea, which are both prokaryotic domains. The eukaryotic domain is eukarya, and that's the domain that we belong in. So bacteria and archaea appear in fossil evidence 3.5 to 3.6 billion years ago. Hannah, I hope you're not eating volcanoes in your spare time. Okay. Yeah, but during this time, the atmosphere is mostly composed of methane, ammonia, and other toxic gases. So it's very different from what the atmosphere is like today, which is mostly like nitrogen and oxygen. So the oceanic and island crusts start to form, and most Archean rocks are actually igneous because they do form from the previous Haitian hot, fiery surface that went down. Do you have a question? Okay, I think they accidentally unmuted, so oh no, how do I go back? It's so sad. Wait, okay. Nothing happened. It's all good. The left arrow was not working. Anyway, so during this time, oxygen actually starts to accumulate in the atmosphere that was originally mostly made of toxic gases, thanks to cyanobacteria, which we will look at what they look like in fossilized form in the next slide. Also volcanoes, because when they erupt, they also go through a process and release oxygen into an atmosphere. So there was also a lot of carbon dioxide because of this, and so the Earth also started to warm up due to the greenhouse effect, which traps heat in the atmosphere. So what are stromatolites? So stromatolites are sedimentary rock formed by cyanobacteria layers in the Archean. So as you can see in the right, those are what actually stromatolites would look like. They look like layers of just like mush and fuzzy gray stuff. And so that would be cyanobacteria. So cyanobacteria are actually photosynthesizing single-celled microbes that form microbial mats that combine with trapped sediment to form stromatolite layers. As you can see, they basically combine with rock sediments to form these mounds. They are the earliest, well, I wouldn't call them the earliest life, but they're the oldest record of life that we have. There's been like speculation about life earlier than that, but these are the oldest fossil records that we have. They're typically formed in shallow water, and the main component of the sediment in their stromatolites are limestone, but also sometimes there is dolostone, and they usually look like mounds, as you can see, and I've already said, and they produced a lot of oxygen because photosynthesis, one of the products of photosynthesis is oxygen, and that is released into the atmosphere. Like trees today that perform photosynthesis also release oxygen, and that's basically why we have oxygen. And so this actually gave rise to something called the Great Oxidation Event. And it's basically an event where animals started evolving and becoming way more complex because there was oxygen, which allowed them to perform many functions. And I realize I may kind of be going fast, so I'm going to send the link into the chat if you guys want to follow along. So oh no, okay, I did it to direct. But yeah, here's the presentation if you guys want to follow along. I'm really concerned about what's happening here. Please do not eat volcanoes. I am not endorsing eating volcanoes. Okay. So after the Archean eon comes the Proterozoic. And this is around a time period of 2.5 billion years ago to 541 million years ago. So during this eon, we see a lot of new rocks that are important sources of metallic ores that you would find today. So like iron, gold, and copper are some examples. They also contain evidence of primitive life forms like cyanobacteria. And so this also brings us to the earliest oxygen-dependent animals that evolved during this eon because of the previous oxygen that cyanobacteria created. So these animals are called Ediacara fauna, and fauna is basically all the animals in a certain region. So these animals are soft-bodied, multicellular organisms preserved in sandstone from that period of time. It's 635 to 541 million years ago. It's also called the Haitianeon time period. So during this time, other animals that evolved include protists. Okay, protists are actually not animals. So in the eukaryotic kingdom, in the eukaryotic domain, there's 4 kingdoms. There's animals, plants, fungi, and protists. So protists are basically everything that are not animals, plants, or fungi. But excluding protists, other animals that we see in this Proterozoic eon are worm-like creatures that we're not 100% sure what they actually are, but they resemble worms, sponges, trilobites, and soft jellied creatures. So there actually has been a lot of debate about whether trilobites actually evolved in the Proterozoic or not. Some say it's early Cambrian, which is part of the Paleozoic. But for the sake of this lesson, we're going to say that they evolved a little bit earlier in the Proterozoic eon. So because there was lots of oxygen coming to the atmosphere, there was a lot of evolution because animals could perform more function while not using that much energy because of cellular respiration, which is really efficient. So some things that came as a result is sexual reproduction, which increases genetic diversity and allows animals to live longer. And we also know that there was a lot of oxygen because of red sandstone, which is sandstone coated with quartz and hematite, which is iron 2O oxygen 3. So we know that there had to have been oxygen for this to form. I'm going to ask everyone, as much as I like monkey, I'm going to ask everyone to keep their real names so we can keep a track of everyone. So you guys can be monkey in the gym kit. I have absolutely no objections to that. So moving on.
Because we can rename ourselves.
Okay. Okay, so I'm aware that people can rename themselves, but just please be responsible and rename yourselves back. Thank you. And thank you, Eleanor. Okay, so what is the Phanerozoic eon? So now we're past the Precambrian super eon, and we're looking at this 4th eon, which we live in today. It started 541 million years to 0 million years ago, and it began with something called the Cambrian explosion, which is a major biodiversification event. So during this time, lots of animals just started popping out of nowhere, and we'll see a couple of groups later. And so the Phanerozoic eon is divided into 3 eras: the Paleozoic, Mesozoic, and Cenozoic. So certain major events that occur repeatedly throughout the eon include these. So they are mass extinctions. So in these events, a large number of species die off. So it can go up to like 96% of all species in a certain area dying off. And then also major glaciations, which include global cooling and the sea levels decrease because everything turns into ice. Other changes in climate and sea level, so not only cooling but also warming. And something you have to note is that these have to be natural changes, not human caused, although humans did not exist in the Paleozoic and Cenozoic, but later, like the global warming we see right now, that wouldn't be considered one of these events because it is human caused. And also it's characterized by a lot of supercontinents. Like I'm sure you've all heard of Pangea, also Gondwana is another one. So what is the Paleozoic era? So the Paleozoic era actually gets its name from something that means ancient life. As we'll see in the next week, the Cenozoic and Mesozoic actually mean middle life and recent life. So the Paleozoic era spans from 541 to 251 million years ago. And as the Cambrian explosion kicked off the Phanerozoic eon, it also kicked off the Paleozoic era, and it lasted around the first 53 million years. So major diversification of complex life in this era. We got our first chordates, our first coral, brachiopods, bivalves, cephalopods. If you guys don't recognize any of these, that's okay. We're going to go over it later. I'm not going to read off all of them because I don't want to basically wrap every single animal in existence. So there are 3 mass extinctions in this era. And the end of the era is marked by the largest mass extinction in history, the Permian Triassic, also called Permian, or the Great Dying colloquially. So the 3 mass extinctions would be the Ordovician, Silurian, and Devonian, and Permian. No, the Cambrian extinction event is not an event, but yeah, okay. So what is the Cambrian period? So 541 to 485.4 million years ago, that was the Cambrian period. We start out with the Cambrian explosion, and we started with these animals: sponges, corals, mollusks, echinoderms, bryozoans, and arthropods. If you guys have, oh, I forgot brachiopods. I'm sorry, brachiopods, I love you. Okay, so it was said that at the beginning of the Cambrian, no animals had hard parts because they haven't been evolved yet. But later, as we can see with the trilobite here, people or the animals started to form exoskeletons. And so trilobites are perhaps one of the most famous fossils in the Paleozoic era, and they dominated fossil record in around the middle to late Cambrian-ish. See, some also say that trilobites evolved in the Proterozoic, which is what I also said earlier, but they just know that they evolved generally from the Proterozoic to Cambrian time period. We also got our first jawless fish, which is very interesting. So, moving on. What are sponges? So sponges are part of a phylum called Porifera or Porifera, and the name means pore bearer, and you'll see why when I read this. They evolved in the Precambrian. They are one of the most primitive life forms on Earth, and they had tiny pores that allowed water to circulate them, and this water would bring nutrients and also help them excrete waste and perform other functions. And so this is also called a water canal system, and it's unique to sponges and one of the ways that we characterize them. Hannah also dropped a definition into the chat that is pretty accurate. Do not take sponges from the ocean and use them for washing and cleaning, please. Thank you. Okay. So, what are coral? So corals are classified under phylum Cnidaria, which means sinking metal. They also evolved in the Precambrian, being one of the most primitive life forms. And they are characterized because they all have stinging cells called cnidocytes that are used for capturing prey. So something also interesting about corals is that they have different stages of life. So the Medusae stage is what you see on the right, that is a jellyfish, and during this stage, they can swim around freely. But then they also have a stage where they stay still in life, and it's the polyp stage. And during this time, they just stick to one place and stay there. And so the individual units that make up huge coral reefs are called zooids. As you'll see in paleontology, zooids are going to be a common recurring theme, and it's going to be what we call individual units of larger colonies, especially in marine animals. So, what are mollusks? So, mollusks are characterized under phylum Mollusca, which means soft. And so they evolved in the Cambrian a little bit later than sponges and corals. And so there are three characteristics that characterize mollusks. Some mollusks actually don't have one of these characteristics, but generally all of them do. So they have to have a mantle cavity, a nervous system, and a radula, which is like a thing they use to scrape food. Sort of like a spiky tongue. So, what are echinoderms? So echinoderms are part of phylum Echinodermata, which means spiny skin. They also evolved in the Cambrian, and something really unique about them is that they have pentaradial symmetry. So I don't know if you guys remember from the first class, but basically it means that they have one point, and then they have like 5 legs or some other thing going from that point. Some have more than 5 legs, but generally speaking, they all have this 5-fold symmetry. They also all have spiky skin, as you probably inferred from its etymology. And as you can see, there's a starfish there, and it has spiky skin and 5 legs. They're perfectly pentaradially symmetrical. So what are bryozoans? Bryozoans are like less common animals that you've probably not heard about, but they are part of phylum Bryozoa. They are also commonly called moss animals, and that's also actually what their name means. They evolved in the Cambrian, and a thing that's not unique to them, but very special about them is that they use a lophophore for feeding, which is like this mouth-like thing with tentacles that trap food as things flow by. Brachiopods also use the same thing for feeding, which we will see in the next slide. So they formed colonies, and the individual units in their colonies are called zooids, as I said in the previous slide about corals. The individual units are often called zooids, and the actual thing is called just like a colony. And so bryozoans are usually classified into different shapes. So there are a couple different shapes that we're going to be looking at their definitions. A bryozoan that's encrusting means that it looks like a flat sheet. If it's massive, if it's a massive bryozoan, it's just basically like a solid mass that's like really big. If it's foliage, yes, it means it's sheet-like. If it's dendroid, it means it looks like a tree. Dendroid generally means it's relating to a tree. If it's fenestrate, it means it looks like a net. So a lot of like individual units with air pockets connecting to each other. So what are brachiopods? Oh God, please don't make me imagine fungus-covered spiders. Okay, so phylum Brachiopoda are the phylum that classifies brachiopods. The meaning of the name is arm, foot, which is not very interesting, but that is what it was named after. They also evolved in the Cambrian and feed with a lophophore, so they are filter feeders just like bryozoans. So they have 2 valves that are in like an upper and lower organization, and that's pretty important because that's what distinguishes them from bivalves, which are a mollusk class. And so they're commonly confused, but something you need to remember is that brachiopods have up and down arrangement, while bivalves have left and right arrangement. So the 2 major groups or classes of phylum Brachiopoda are articulata and inarticulata, or articulate and inarticulate. And so the main difference is that articulate brachiopods actually have tooth and groove features on the valve hinge, whereas inarticulate brachiopods don't. All brachiopods, however, do have a pedicle that attaches themselves to a substrate. It looks like a weird sucker thingy, and they kind of look like a clam or a bivalve. So, what are arthropods? They're part of phylum Arthropoda. Again, with the creative names, now we have joint foot. Yes, this is the phylum of spiders and bugs and those annoying cicadas that are not outside anymore, thankfully. So they also evolved in the Cambrian. They have an exoskeleton made of chitin. So chitin is actually a material found in the cell wall of fungi usually, but in the animal kingdom, arthropods actually have exoskeleton made out of chitin, and it's basically just a polymer. All arthropods have an exoskeleton made out of chitin, a segmented body. As you probably know, ants have 3 segments, and also most arthropods do, and also paired jointed appendages, which is basically just pairs of legs. Yes. So, what are trilobites? So, trilobites are under class Trilobita, and so trilobites are actually arthropods. As you can see, it kind of looks like a bug. They are the ancestors of beetles. And so this name is a little bit more creative, but not really. Trilobita means 3 lobes. And so they evolved in the Cambrian, but they went extinct at the end of the Paleozoic. They are really famous fossils from the Paleozoic because they are found everywhere. And they are good index fossils because they evolved a lot in a short amount of time. At the end of the Paleozoic, even though they went extinct, they still managed to leave a really, really, really big mark on fossil history. So there are marine arthropods that are arranged in a 3-lobed, 3-segmented form. So you have the head, the body, and the tail, and you also have the left, middle, and right arrangement. And that's what's pretty unique about trilobites. They are the ancestors of beetles, which is pretty cool. So moving on to our next period. The Ordovician period spanned from 485.4 to 443.8 million years ago. Oh no, wait, is it good now? Okay, good to hear. So, during the Ordovician period, trilobites evolved a lot. They had all sorts of new eyes pop up. And there's actually a trilobite that is basically blind, but also some of them have like thousands of crystal compound lenses, and it's really cool. So, during this time, we got our first planktonic rhabdolites, blastoids, bryozoans, corals, crinoids, or new forms of bryozoans, and as well as many different kinds of brachiopods, snails, clams, and cephalopods. If you guys don't know what some of them are, that's okay, we will go over it. So also a pretty significant thing during the Ordovician period is that animals actually started to colonize land because the atmosphere was changing. There was a lot of global cooling and glaciers. And so the Ordovician period ended with the Ordovician to Silurian mass extinction, where 60% of marine organisms died. And so, however, during this mass extinction, it didn't wipe out a lot of sponges, even though it wiped out a lot of other animals. So sponges started to dominate right after the Ordovician period. So, what are graptolites? So, subclass Graptolithina, they are part of phylum Hemichordata, which is a phylum for acorn worms. And so they look like letter markings and pencil writing, so that's why they're called letter markings. Well, they're not called letter markings, but their name means letter markings. And so they evolved in the Cambrian, but they became more prominent during the Ordovician, and they went extinct in the Carboniferous period. And so they are colonial animals that look like hieroglyphs written in rock in fossil form. As you can see in the image below, they do look like pencil markings. So what are blastoids? Class Blastoidea, they are part of phylum Echinodermata, and they are echinoderms, and their name means bud because they look like a little flower bud in fossil form. So they evolved to the Ordovician, and they went extinct in the Permian, so at the end of the Paleozoic. They have flower-like food groups with brachioles to guide food into their mouth. As you can see in the image on the right, the arm things that stick up, those are brachioles. And then, as you can see in the image on the left, the flower things are their food groups. So they also have 5 plates surrounding the body mass, which contains their organs like the anus. And so genus Precambrian is a pretty famous index fossil for the Carboniferous, and it is a blastoid. So, what are crinoids? So crinoids are also echinoderms, and they're class Crinoidea, and their name means lily-like. They are my favorite echinoderms. So they evolved in the Ordovician, and they're still alive today. Angelina, I like your cupcake background. Oh no, it's gone now. Never mind. Okay, so they have more than 5 arms, as you can see, and so their body is also covered with a plate, and their main body part includes the stem, the calyx, and the arms at the top. So the calyx would just be the cup thing that the arms extend out. And they are very important Paleozoic index fossils and very common. So what are cephalopods? Oh boy, another great named animal. Yeah, okay, so they are mollusks, and they're part of class Cephalopoda. Their name means head feet. Okay, so
are those fish?
Hmm?
Do they qualify as fish?
Do they what as fish?
Qualify as fish?
Okay, so they are not fish. So, I mean, technically speaking, I guess in culinary terms, they do count as fish, because, like, I guess you would say an octopus is a fish you can eat, but no. So fish are part of phylum Chordata, while cephalopods or mollusks, they are part of phylum Mollusca. So like octopuses, squids, they are all part of a completely different phylum than fish are in. So no, please do not confuse them, but thank you for asking. So they evolved in the late Cambrian. They have bilateral body symmetry, just like us, which means that if you split us down the middle, and we're pretty much symmetrical, they have a very prominent head. As you can see in the octopus, their heads are pretty big. They also have a set of arms or tentacles, modified from the primitive masculine foot. So the foot is also another characteristic of the mollusks. Like in snails, the foot is like the thing they use to inch on. In mollusks, it would be in cephalopods, it would be like their tentacles. They're the most intelligent invertebrate because of their heads, and they also move by jet propulsion, which is like basically squirting ink and moving forward because of the propelling. So what is the Silurian period? Moving on from the Ordovician, the Silurian period was 443.8 to 419.2 million years ago, and during this time, the climate started to stabilize, the sea levels rose, and here we got our first coral reefs. Land fishes, oops, I clicked, okay. Dogfishes, vascular plants, and we had a lot of arthropod, crinoid, and brachiopod expansion in fossil records. So vascular plants are basically just plants that have vascular tissue, so they can transport water and food throughout their xylem and phloems and grow really big. So what is the Devonian period? The Devonian period came after the Silurian, and it lasted around 419.2 to 358.9 million years ago. During this time, we got our first tetrapods, or animals with 4 limbs, and insects on land. And we also got our first winged insects and spiders or arachnids. So we also had our first tall, rooted gymnosperm trees by the end of the period. So gymnosperms are plants that have seeds but don't produce flowers. Ones that do have flowers are called angiosperms, and those come later, evolve in the Cretaceous or the end of the Mesozoic. So they're also called the Devonian period is also called the age of the fish because of the amount of evolution that fish experienced. We got armored fish, rayfish fish, slope-fin fish, cartilaginous fish. So we got a lot of fish. So what are armored fish? Armored fish is the common name for class Placodermi, part of phylum Chordata, and so their name means plate-skinned. They evolved in the early Devonian, and they went extinct by the end of the Devonian. These fish have no teeth, but instead they have bony plates. And so the Dunkleosteus fish I showed at the beginning of this class is actually a part of class Placodermi. So their head and thorax is covered by bony plates, whereas the rest of the body either has no plates or is covered by small plates. And as you can see in the bottom image, this is genus Bothriolepis, one of the more primitive placodermy fishes. But what are ray and lobe-fin fish? So class Echinoderms, part of phylum Chordata, this means rayfin. They evolved in the late Silurian, so rayfin fishes have fins that are webs of skin supported by bony or like sharp, horny spines. So as you can see in the left picture, their fins are like really bony. So lobe-fin fish are part of class Sarcopteridae, and so they are part of phylum Chordata. Their name means flesh fin, and so they also evolved in the late Silurian, but instead of having bony fins, they have very flexible lobes in their fins, which supports life on land because they can stand. So the main difference is to remember is that rayfin fish have fins that are tough, and lobe-fin fish have fins that are really fleshy. So lobe-fin fish actually went on to evolve and form the rest of the tetrapods. So what are cartilaginous fish? So class Chondrichthyes, also part of phylum Chordata, their name means cartilage fish. They evolved in the late Silurian. Also, just a note, if I don't say something went extinct, that means they're still alive today. So these fish are jawed vertebrae that have paired fins, gills, pairing nares, scales, a cartilage skeleton, and a heart with like its chambers and series. So stingrays are actually a part of this class, and it's pretty interesting. So moving on to the Carboniferous period. So this period was 358.9 to 299 million years ago. Derives its name from the massive deposits of coal found in the UK and Western Europe. So coal is a form of processed carbon. So this is sometimes divided into the Mississippian and Pennsylvanian periods, especially in North America. During this time, crinoids, blastoids, bacteropods, bryozoans, and fusulinids flourished. But trilobites started dying out during this period before going completely extinct in the next period. So in this period, we also got huge forests. And so that was a really, really distinct feature of the Carboniferous. And because we got huge forests, we also got more oxygen. So we had 80% more oxygen in the atmosphere than what we have today. So that's why there was giant insects in the Carboniferous. I would not want to have lived in that period.
You need a giant fly swatter.
Why don't you go back in time and invent one? I would buy one. Okay, so we also got our first reptiles and the ammonite egg. So the ammonite egg basically means that the egg had like a yolk sac and a covering, so you didn't need to be in the water to ensure the survival of this egg. So this also led to reproduction on land. Very cool. So what are Fusulids? So they are part of order Fusulit, and they are part of phylum Foraminifera. The etymology is pretty hard to find for this one, so we actually don't know what the name means. They evolved in the late Silurian, and they went extinct at the end of the Permian. They had a hard shell known as a test, and this shell was made out of calcium carbonate, and so that made it really, really easily preserved. Oh, it's also, yeah. So, okay, it's also a protist. It's not an animal, so just keep in mind of that. So, what is the Permian period? The Permian period is the final period of the Paleozoic era, and it was from 299 to 251.9 million years ago. During this time, we had lots of diversity, especially in synapsid reptiles, which we will look at in the next slide. So these were bulky, cold-blooded animals with small brains. So at the very end, archosaurs appear, and they are the ancestors to dinosaurs, and it ended with the Permian Triassic extinction, the largest extinction of history to this day. So what is the Permian Triassic extinction? It's also called the end Permian extinction, which is personally my preference for its name, and it's also informally called the Great Dying. It is the boundary between the Paleozoic and Mesozoic eras and Permian and Triassic periods, which is also why it's called what it's called. And so some say it lasted only 200,000 years, while some say it went from 299 to 251.9 million years ago. It is the most severe extinction ever, with 90% of plants, 96% of ocean animals, 70% of land animals all dying off. Many important animal groups went extinct, and these are a few to list them.
Wait, why did they die off again?
So they died off because of the impact that the extinction actually had. So we'll look at the causes in the next slide, but it was basically just a lot of factors that led to them not being able to survive. So it also heavily...
Wait, so they couldn't adapt? Or
I think it was, okay, so animals actually don't evolve that fast. To evolve faster than the pace at which they are dying off is like, so there were some animals that went on to carry over the population from the Paleozoic to the Cenozoic, but it was really hard for them to keep up with all of the changes because there was so many, as we can see in the next slide. Wait, okay, so this slide is out of order, but what are synaptodes real quick? Class Symnopsida, phylum Chordata, and their name means together arch. They evolved late Permian, and they are distinguished by a single hole known as a temporal fenestra in the skull of each eye. So as you can see, tigers, dinosaurs, they're all synapsids. So what caused the Permian Triassic extinction? Now, as you know, animals don't just die off because they're bored. So there was a lot of different speculations on reasons, but it was hard to have any concrete evidence because of how long ago this actually took place. As I said in the beginning, a lot of fossils is just really, really, really educated guesses based on lots of evidence, but nothing concrete. So there were mainly two groups of evidence or causes that paleontologists seem to have believed caused the Permian Triassic extinction. One of the categories was catastrophic. So these are like your unexpected natural disasters. One or more bolide impact events, which are like meteors hitting the Earth, increased volcanism, volcanoes erupting, and sudden release of methane from the seafloor, either because of the dissociation of methane hydrate deposits that released methane, or the metabolism of organic carbon deposits by methanogenic microbes. So we have microbes that photosynthesize and produce oxygen, but some microbes actually also produce methane. So this could have been a reason. Gradual, which means that there was a lot of buildup over time. So this would include sea level change, increasing anoxia, increasing aridity. And so the air was just not as moist. And also you need to keep in mind that most of the animals at this point are like shells. And so a lot of the skeletons of these animals are made out of calcium carbonate, which is really sensitive to acids. So when met with this increasing acidity level, their shells would start bubbling. But there is hope. What is a disaster taxon? It's also called a pioneer organism, and it's basically an organism that repopulates a region after a natural disaster or mass extinction or any other event that kills off the majority of organisms in an area. And so, really famous disaster taxon from the Permian Triassic extinction is the genus Lagerstatten. As you can see from the image on the bottom, this is what they are drawn to look like. So, finally, gym kit time. So,
Wait, can you send us a link?
yeah. Wait, to the slideshow or the gym kit?
The gym kit.
Okay, I think we have to wait and see the code. So, what
Wait.
game or what
Wait,
mode do you
trust
guys
no
want
one.
to play?
Trust no one. Trust no one.
I'm waiting for votes. Okay, so we have 1 vote for Trust No One, 1 vote for Drawing Angelina with Classic. Trust No One. The floor is oh
Trust
wait.
no one.
Okay. Let's do Trust No One then today. Number of imposters. Okay, let's just do 1 imposter for now.
Actually,
That's
we
my
need like 3 because
We should
there's
get-
a lot of people.
Yeah, we should get 2 to
Okay.
3.
Okay, let's do 2 then, because I don't think we have that much time. Investigations per week.
Do you have it as or that? I'm gonna say have the investigation reality as normal, but
Oh. Okay, yeah.
That just makes it harder though. It'll take longer.
Okay, let's do very reliable for today. Because we don't have that much time. Okay. I have no idea how this goes. I'm going up. Wow, monkey. The fish, ooh, chocolate. Okay, so I guess I'll wait like 30 more seconds because we don't have that much time. Okay, we have an artist in here. Okay, I'm gonna start now and
Can you wait like a minute? Just like a minute.
okay. I've been requested to wait, so I shall wait. Can I begin? Is everyone in?
Wait, I'm not in yet. I'm having
No.
trouble.
Okay.
Just be like a minute or 2.
Okay. I'm gonna, if you're not in by 53, I'm just gonna start real quick. Okay. I'm going to begin.
My clock says 52 still.
Okay. Then you have 10 seconds to speedrun this.
It's 53.
Okay, I'm going to begin now. All right, let's go. Should I skip instructions?
No, we don't know how to play.
Okay, fair. I don't even know how to play.
We've played it before.
I have no idea what. Okay, I'm just gonna
I
skip
played it before. So you just earn coins and then.
Wait, okay, so I can't actually see anything, but you guys can see stuff,
Wait,
right?
if you're if you're like late in the game, can you still play?
Try joining.
But I don't know the pin.
Yeah, what's the pin?
It's in the bottom left corner. I have no idea what's happening right now, but I hope you guys are having fun. Oh. Wait, are you guys supposed to see the investigation log?
Yeah, I think so.
Yes, you are.
Okay, I'll just put this up. Stuck as in how? Stuck. And how do we unstuck you?
To fix your problem, at the top left, you have like a 3 bars, and then if you click on that, you can click on questions.
Okay, yeah, what?
It's only on our screen.
Okay. Also, I hope you all know that in our last fossils class, it's just going to be all like a Quizlet, and all of the questions are going to be, is this copal or amber? So just be prepared for that. Come on, guys. I believe in you. Who is the imposter? Okay, so if you know the imposter, aren't you supposed to like call a meeting or something? I've never played Among Us because I'm a boomer, but
No, I think only you can call the meeting.
oh,
Yeah, so we have to ask you.
What
okay.
are we?
So
We discuss out loud, or is this just?
yeah, I
We need
guess
to
so.
discuss out loud.
It's not Athena. It's not Athena.
It's not Ming Mei.
Okay, Sam
It's
says that.
Monge.
Probably someone's name who's monkey. So many. So if you know math, so
We don't
if
have
you
enough
know
Can we just
information.
skip?
math,
Because
We don't have
there's
enough
a
information to
probability.
continue.
Okay. Yes,
Let me skip.
just vote.
There's not that much evidence, so.
How godly are you guys?
Only tell them to do it if they ask you to, because I think we've got a limited amount.
Okay, so
I just
say
ran
monkey. Capital M monkey seems to be the consensus.
I just randomly guessed because I don't have anything.
Okay, I'm just gonna end voting now so we have more time. We get an imposter. Oh no, I'm sorry, monkey. They were not an imposter?
Screen
Yeah,
is
they weren't.
frozen. The screen is
Oh
frozen.
my god!
Oh my god.
Wait, are you?
That
That's so
was
funny.
good.
Wait, you guys are
Yes.
godly. Holy crap. Holy jeez. Holy crap. Okay. Okay, we don't have much time left, so I'm just gonna call a meeting right now, and you guys can vote on who you guys think is the imposter, and then we shall end class.
So I investigated Apollo, and the result is inconclusive. It's very
Okay.
sus. So just
So,
putting that.
okay.
Because that happens, it means you have to. It doesn't mean he's an imposter.
I'm just
Doesn't
putting that out.
mean-
Why
It's like-
we? There's no other information to go off of.
They
Choose a
just
random monkey.
What do you think it is? Choose someone else.
Okay. Just vote for who you guys think it is.
Vote the other monkey. I was kidding.
There are so many monkeys, and there's 2 Lala.
Okay, once we reach like either 20 votes or 9 o'clock and 30 seconds, I will end the voting. Okay, so voting ends now. Let's see who was voted off. Random, okay. Okay, I don't think they were an imposter.
Wait, what?
Wait,
What?
wait.
That was
So
quick.
quick.
That
We're
was-
lucky.
So lucky.
I didn't even get to use my.
Holy
edit.
crap.
Only 2 meetings we
Yeah,
guessed.
random. I don't know what you guys are doing out here, but you're not
Somebody
doing
That
very
man is
well.
big brain.
Be a big
somebody
brain.
hacked.
Hacks.
Holy
Hacks.
crap.
Espionage.
Okay, well, good job, everyone. I'm very impressed. So your homework options, you can either spam the ID bot or try this Quizlet or find out why I like monkey.
Wait, what's the ID bot?
The ID bot, if you join the Sage Discord, let me send the link right now. But in the Fossils channel, just do FF and you'll see. Okay, but
I don't
Yeah.
know, but you might have like last time you said like I think maybe it was someone else, but maybe you said like it was in my browser, and it was the atom things and particles. And
oh,
I didn't quite understand.
okay, so that was a lab I think you're supposed to play around with. Basically, if you wait, let me pull the lab up right now. Everyone else have a nice week.
The Trustno one is about research, right? Like-
No.
Like for the Quizlet thing, it's the Trustno one. It's about stealing a research, right? You know, if it were me, I'd make it about like corporate espionage or something like that.
You should pitch that idea.
Yeah, corporate espionage or maybe, I don't know, nuclear launch codes. You know, just make the stakes a little bit higher instead of research.
Yeah, okay. I will look into that next week because I haven't. No idea. How
I mean, I'm
Jim
not
can't-
sure if you can change it, but still.
Let me look at the lab from. So radioactive dating is how we fossil date. Yeah, so fossils, sorry, not fossils. Discord does have a terms of service. Terms of service, and you can't can't join if you're too young. So I'm sorry, Angelina. Yeah, fossils. If you're under the age of 2 months, you're not allowed to do. Wait, let me just.
Is there anyone who actually waits for 13 to go get Discord? Like, is there anyone who actually waits for it?
Are you admitting to crime?
What? It's a crime?
Yeah, you can get sued.
I mean, no one's enforcing it though.
True. Okay. So we might not have time to.
Dating
at-
game sim is a very
Okay.
interesting title.
All right. But yeah, Eleanor, you can take a look at that video because I don't think we have time to go through it and go through the lab in its entirety. But yeah, otherwise, I will see you guys all next week.
Bye.